Hello, good morning all. So, it's me Vasil. My seminar topic is verification of laws of refraction and refraction using Fermat's principle. It will take a lot of space, that's why I have. So, what is Fermat's principle? In the previous class, Delta explained the Fermat's principle. What is Fermat's principle? Correct answer. Fermat's principle means light always travels between two points along path that makes least time. Like we know, light is also lazy like us. Light also don't want to use so much energy or so much heat. It always chooses the path which takes very less time to travel. Right? So my topic is not Fermat's principle. My topic is verification of laws of refraction and refraction. While taking Fermat's principle, Telpa introduced the relation also, like dt by dx is equal to 0. Why is that? Because we know, according to Fermat's principle, time will be minimum. Okay? We studied in second sem and first sem application of derivatives. We studied that the derivative of point of local minimum is 0. Point of minimum value is 0. Derivative of minimum is 0. Like that, minimum points local will be 0 like that. We don't need that thing. So first I will verify law of refraction. Okay? Verification of law of refraction. Verification of law of refraction. What are the laws of refraction? We know first law is that incident ray, refracted ray, normal, incident angle, refracted angle, everything will be same way. Second law is angle of incidence equal to angle of refraction. That is the law. We will prove that law here. Okay? For that, consider plane. Okay. Incident ray coming. It will hit the plane mirror. It will go in a certain way. And here we have movement. And the angle between incident ray and normal is angle of incidence. I am taking theta. The angle between normal and refracted ray is theta. And I am taking this height as h1 and this height as h2, and I am taking this length, the length from this side to this side. This length I am taking as x, and this total length from here here, this total length I am taking as a. This is x and this is l. So what will be this length? L minus x. This length is L minus x. Picture is clear now? Let's give some names like incident ray is AO, reflected ray is OB, and this mirror is F9. We need to prove angle of incidence equal to angle of reflection. That means theta 1 equal to theta 2. We need to prove theta 1 equal to theta 2. Okay. We can find the time, this time taken by this light ray to travel. We know time is distance by velocity, distance by speed. The distance is the light ray traveled from A to O, then on to B. So the total distance is AO plus OB. And what is the distance? Let's say it is traveling in a velocity v. What is AO here? We know this side is h1, this side is x. Here Pythagoras comes, Pythagoras theorem. AO is equal to root of h1 square plus x1 square. H square plus b square. AO is equal to root of h1 square plus x square. plus OB. What is OB? OB is same Pythagoras theorem again. Like h2 square plus L minus x whole square. Root of h2 square plus L minus x whole square. Whole divided by v. D got D. Now we can use that relation. Like I told you, dt by dx is equal to 0. If the time is minimum, dt by dx is equal to 0. According to Fermat's principle, we can apply this. So let's find the derivative of d with respect to x. Okay, let's get it. Here v is a constant because we are derivating with respect to x. So let's take v outside. 1 by v into, what is the derivative of root x? 1 by 2 root x. V into 1 by 2 root h1 square plus x square. X square is there. So we are multiplying 2a plus, again, what is the derivative of root this thing? It will be 1 by 2 root that. 1 by 2 root h2 square plus L minus x whole square into minus x. Into minus into minus equal to 0. Okay? Now, we can take this 1 by b outside. V 1 by b into 0 will be 0. That term will be gone. Okay? This side, 2 and 2 will be cancelled. X by root h1 square plus x square will be there. Plus minus this term will be cancelled. Here will be minus 1 by root x square plus n minus x square. We can take this minus then right. That means x by root h1 square plus x square equal to here L minus x by root h2 square plus L minus x equals here we mistake it. Derivative of 1 by root x is 1 by 2 root x into derivative of this thing. Derivative of h2 square will be 0. Derivative of L minus x whole square will be 2 into L minus x. That's that time minus 2 into L minus x. Now it is okay, and that minus is here. 2 and 2 will be cancelled. That L minus x will be okay. Now, from this picture, we can find sin theta 1 and sin theta 2. Okay? Sin theta 1 and sin theta 2. Let's find. This is theta 1. Sin means opposite side by hypotenuse. What is opposite side? Opposite side is x here. X by. What is hypotenuse? Hypotenuse is a over by Pythagoras theorem. Root h1 square plus x square. Root h1 square plus x square. Now what is sin 2? Sin theta 2. Sin theta 2 is same way. Opposite by hypotenuse. Opposite is L minus x by hypotenuse is L minus x whole square plus h2 square. Now compare these things. X by root h1 square plus x square. That is sin theta 1. And L minus x by this way. That is sin theta 2. So we can substitute by that. That means sin theta 1 is equal to sin theta. We can take sin inverse on both sides. That means we will get theta 1 is equal to theta. Okay. We need to prove this thing. That means we proved second law of refraction. Now let's move to law of refraction. Now let's move to verification of law of refraction. So there were two laws of refraction. First law of refraction was correct. Incident ray, refracted ray, normal, angle of incidence and angle of refraction will be same way. And the second law was Snell's law. We are familiar with the name Snell's law. What is Snell's law? Snell's law was n1 sin theta 1 is equal to n2 sin theta. Okay? n1 by n2 is equal to sin theta. Now we need to prove that one. So for that, let's consider the refraction. We are refracting medium is there. And incident ray is coming. It's going to refract. Incident ray, refracted ray, normal. Same thing like we did in the verification of refraction. We have to draw two lines. I am taking this length as x. I am taking this whole length as L. So this remaining length will be L minus x. Okay. I am taking this height as h1. This height as h2. This ray is A, O, B. This ray or this is taking as Mn. And in refraction medium, two mediums have two refractive indexes. One medium have n1, another medium have n. So we know what is the equation of refractive index. N1 is equal to c by v1. Okay, like that n2 will be equal to c by v. Now, similarly, first we can find the time taken by the light ray to travel from A to B. So time is equal to distance covered by speed. That means first this distance covered is AO, and at the medium one it will have a velocity v1. Then the distance covered is OB, and in medium 2 its distance will be v. Its speed will be v. By the Gauss theorem we know what is AO. AO is h1 square plus x square. Root of h1 square plus x square by what is v1? n1 is equal to c by v1. So v1 is equal to c by n1. v1 is equal to c by n1 plus OB. What is OB? By the Gauss theorem, OB is equal to root of h2 square plus root of h2 square plus L minus x whole square by what is v2? V2 is similarly v2 will be c by n2. Okay. Now the same formula we applied before. dt by dx is equal to 0 by using Fermat expression. And we are applying. Let's find the dt by dx first. So I am taking this c by n1 outside. n1 by c is square constant. What is the derivative of 1 by root x? 1 by 2 root x. 1 by 2 root x. Derivative of this term will be n2 by c. 1 by 2 root h2 square plus L minus x. Into L minus x. Into minus. Clear? Equal to 0. Okay? Now, 2 into 30. Then we can rewrite this as n1 by c x by root over h1 square plus x square minus n2 by c L minus x by root of h2 square plus L minus x. How this become minus? This minus 1 will equal to 0. And taking this delta that side. So it will become L1 by c x by root of h1 square plus x square equal to L2 by c L minus x by root of h2 square plus L minus x whole square. You see? Okay. What was x by root h1 square plus x square? We discussed in the previous class. It was sin theta. So if the angle between incident ray and normal is theta, angle between refracted ray and normal is theta. So sin theta is opposite side by hypotenuse. That means opposite side means x by hypotenuse. That is root h1 square plus x square. That means this is sin theta 1 and this term will be sin theta 2. Let's check. This is theta 2. Sin theta 2 means opposite side, that is L minus x by hypotenuse, that is OB. OB is root of h2 square plus L minus x. So this term is sin theta 2. So we can rewrite this as L1 sin theta 1 equal to L2 sin theta 2. What is this? This is what is Snell's law. So we verified it. Law of reflection and law of refraction successfully. So then let's move on to two simple problems. You can write your point source of light is located 20 centimeter in front of a convex mirror if f is equal to 15 centimeter. Determine the position and character of the image. Is given that the distance, the point source is 20 centimeter in front of convex mirror. That means u is 20 centimeter and the focal length of convex mirror is 15 centimeter. We need to find the position of the image. We need to find it. We know the sign convention. In convex mirror, the position of image u will be taken as negative and focal length will be taken as positive. We need to find v. We know the formula 1 by u plus 1 by v is equal to 1 by u. We need to find v. So 1 by v is equal to 1 by f minus 1 by u or u minus f by uf. So v is equal to uf by u minus f, that is minus 20 into 50 by minus 20 minus 50. We will get the answer as 8.6 centimeter. So the image will be at 8.6 centimeter away from the pole. So that's all my topic. We verified a law of reflection and law of refraction using Fermat. If you have any doubt, you can ask.